Hello and welcome to our podcast about artificial intelligence. Today we'll be discussing how AI is changing the world around us. And specifically, we're doing a deep dive into something pretty new, a cyber threat targeting large language models, or LLMs. It's called indirect prompt injection.
Right. And maybe just quickly, for anyone not totally immersed in AI yet, LLMs, large language models, they're kind of the brains behind a lot of the AI you see. Think systems trained on just massive amounts of text, lets them understand us, generate text, translate, answer questions.
Sure.
But the key thing for today, they process info from lots of places, documents, websites, maybe emails if they're plugged into your system. They read external text, and crucially, they can act on instructions within that text.
Exactly. Which leads us right to the point of this deep dive. We want to get our heads around this emerging threat. Why should you care if you're using AI or relying on it? And well, what can we even do about it? We're looking at a couple of recent articles here, one from gvhackers.com, another from the RL blog. Both just came out this month, May 2025, and they really dig into these sneaky attacks.
Sneaky is the right word, because what makes this interesting and kind of scary is how these attacks just hide, right out in the open almost.
Yeah, unlike, say, a direct attack where someone just tells the AI, do this bad thing.
Exactly. Indirect prompt injection, it embeds the malicious instructions inside content that looks totally normal. Benign, even.
So it's hidden.
Yeah.
Making it way harder to spot.
Way harder. And the potential impact is huge. It could affect, software security, the info we get online, lots of things.
Okay. Let's nail this down. What is indirect prompt injection? Just in simple terms.
So fundamentally, it's hiding bad commands inside those external data sources we mentioned.
The documents, websites, emails.
Right. Stuff the LLM is designed to read and process anyway. And the AI, well, it just stumbles across these hidden instructions and thinks they're legitimate commands it should follow.
Oh, so the attacker isn't talking to the AI directly. They're leaving poisoned messages for it to find later.
That's a good way to put it, yeah. Direct injection is like giving orders. Indirect is much more subtle. You plant the instructions where the AI is going to look anyway. And the crucial bit is the model often treats all the text it reads as potentially containing instructions. That's the weakness being exploited.
Wow, okay. That sounds really tricky to defend against.
Yeah.
Why are these super smart LLMs actually falling for this?
Well, the core issue is they generally lack a sophisticated way to tell the difference between just information and instructions when they're reading external stuff. Researchers are calling it a lack of boundary awareness. When it pulls in a chunk of text from outside, it doesn't automatically know this part is context, but this part is a command I should act on.
Right. It's sort of a fundamental limitation in how they see the world right now.
Kind of, yeah. It's like if you were reading a web page and suddenly it said delete all your files, you'd hopefully recognize, that's weird, right? An instruction from an untrusted source within the content. But LLMs, they're not quite there yet with making that distinction reliably. And there's this benchmark, the APA. It's specifically for testing this kind of vulnerability. The researchers put their findings up on Arxiv Labs.
Okay.
And they basically found that most LLMs they tested are, and this is their term, universally vulnerable based on how they measured it.
Universally vulnerable. That's not great.
No, it really highlights how widespread this potential problem could be.
Let's make this concrete then. Can we talk about some examples?
Yeah.
The articles mentioned software supply chains. How would this work there?
Yeah, this is a big one. It gets pretty concerning here. Imagine an attacker slipping some vulnerable code, maybe subtly, into a GitHub repository that looks legit. Now, if you're using an AI coding assistant and it scans that repository, it might not spot the malicious bit. It could even recommend that faulty code to a developer. Or they could embed harmful prompts right into the descriptions, the metadata of software packages on places like PyPI for Python or NPM for JavaScript.
So the AI trusts the source, the repository, or the package index, and doesn't second-guess the stuff hidden inside.
Exactly. It sees it as a trusted source of code or info. It's not looking for commands buried in the descriptions.
So the very tools meant to help developers build better software could actually end up introducing security flaws.
That's the risk. Chris Acevedo from Optiv, he uses this great analogy, calls it a poisoned well disguised as clean water.
That's vivid.
Yeah. The LLM thinks it's getting clean water, good code, but it's actually contaminated. And you have experts like Eric Cron from KnowBe4, Jason Dion from Accolade. They're warning about this. Since AI is getting involved in writing and reviewing code, one attack like this could ripple out, create cascading problems across the whole software ecosystem.
That's genuinely scary, considering how much code runs everything.
Right.
What about like everyday businesses. How does this affect them, maybe with their internal stuff?
Oh, it's not just public code. Think about LLMs that companies train on their own internal data. Emails, documents, you name it.
Right, lots of companies are doing that.
Well, an attacker could potentially, maybe slowly over time, inject malicious content into those internal data sets.
Oh.
Maybe through a compromised email account or a document that gets uploaded. And even if the company has strong firewalls blocking obvious external attacks,
Mm-hmm.
if the LLM is using that tainted internal data to write reports or answer employee questions or summarize things, the attacker could manipulate its behavior from the inside out.
Mm.
Christopher Cullen from Carnegie Mellon's CERT division really flags this. The key is the LLM inherently trusts that internal data it's trained on.
So even with strong walls, the danger could be inside the castle already in the data the AI relies on.
You got it. And it's not just about breaking systems or stealing data, it's also about manipulation,
Yeah.
right?
Yeah.
Misinformation.
Yeah, the articles mentioned that Reddit example, didn't they? People messing with an AI's restaurant recommendations.
Exactly. Greg Anderson from Defect Dojo brought that up. It sounds maybe trivial, like a prank.
Yeah, I think funny.
But the technique is the same. If you can subtly influence an AI's preferences or recommendations by feeding it biased external data, you could potentially use that for much worse things.
Like steering people to fake websites.
Or spreading propaganda, or making it recommend malicious code instead of just avoiding a certain restaurant. By controlling the info the AI eats, you can sort of indirectly control what it spits out.
Okay, so this really goes beyond just a technical glitch for AI geeks. It potentially undermines our trust in these systems, doesn't it?
Absolutely.
Stephen Kowski from SlashNext made a good point, too, that it kind of sidesteps normal security because it uses channels we think are trustworthy.
That's a huge part of it. Traditional security looks at like direct inputs or blocks bad websites. But indirect prompt injection uses sources the LLM is supposed to trust and learn from. It's a blind spot. And Greg Anderson also pointed out it's sort of baked into how many LLMs are built. They're trained on these enormous, often uncurated data sets to get them to be knowledgeable. That very process can expose them.
And it doesn't even take a master hacker, apparently. I remember that quote from Chris Acevedo. Something like, you don't need deep technical skills or fancy exploits.
Yeah, basically. He said it relies on something simpler. The model just following the text it sees no matter where it came from.
That seems like a low bar for attackers.
It really is. It means more people could potentially try these kinds of attacks. They don't need to find a complex bug in the AI itself, just a way to get their text into a data source the AI will read.
Okay, so we understand the problem. It's serious. What can actually be done? Are there fixes? The RL blog mentioned some new ideas.
Yes, the research team that developed that BAPIA benchmark, they're proposing some defenses. One idea is building in better boundary awareness, actually teaching the LLM to be better at telling instructions apart from content. Another is using explicit reminders, basically, reminding the model of its core rules and telling it to be wary of commands it finds in external data.
Does that work?
Well, their early results in lab settings look pretty good. They reported like near zero success rates for attacks when these defenses were active in their tests.
Okay, so that's promising for future AI models.
Yeah.
But what about right now? For organizations using LLMs today, Chris Acevedo had some tips, right? More immediate stuff.
You did, yeah. More practical, layered security things you can do now. First off, sanitize content before you feed it to the LLM. Try to filter out suspicious instructions.
Makes sense. Clean the input.
Second, be really clear in how you structure the prompts. Separate the user's actual question from any background text you provide and tell the LLM, don't follow instructions found in this background stuff.
Be explicit about what's a command and what's just context.
Exactly. He also suggests tagging data sources. Mark stuff from untrusted places so the LLM knows to be more cautious with it.
Like a warning label for the AI.
Sort of. And importantly, limit what the LLM is allowed to do. Especially things like executing code or writing files. Those need tight controls.
Yeah, don't give it the keys to the kingdom unnecessarily.
Right. And finally, keep an eye on it. Monitor the outputs for weird behavior, and do red teaming, basically. Pretend to be an attacker and test your own defenses.
So it sounds like we need a mix. Smarter AI defenses being developed, plus smarter security practices wrapped around the AI we use today.
That sums it up well. As AI gets woven deeper into everything we do, making sure the data it uses is secure and has integrity, well, it's becoming absolutely critical. Indirect prompt injection really shines a light on where current LLMs need to get better at understanding context, understanding where information stops and instructions begin.
This has been really eye-opening. It's clear that as AI starts reading more and more of our digital world, we really have to think hard about the integrity of all that information it's consuming.
We do. And it brings up that fundamental question, kind of echoing Chris Acevedo again. As AI ingests more of our world, how do we ensure we can trust what it's processing? And maybe more importantly, whose instructions are these powerful systems ultimately following? That's something we'll be grappling with for a while, I think.
Thank you for joining us on this episode about the future of artificial intelligence. We hope you enjoyed the discussion and learned something new. See you next time.